Hello, my name is Sean Kugele, and this is a pre-recorded presentation for the 2020 International Conference on Cognitive Modeling. I'm a graduate student at the University of Memphis in the Department of Computer Science. My research advisor and co-author of this paper is Stan Franklin, who is the creator of the Lida cognitive architecture. In this presentation, I'll be giving a brief overview of our paper entitled A Study in Activation Towards a Common Lexicon and Functional Taxonomy in Cognitive Architectures. Our goal in this paper was to review the use of activation in a representative sample of cognitive architectures, and to distill what we learned into a vocabulary of activation-related terminology and a taxonomy of activation-related functional themes. In total, we reviewed 78 cognitive architectures, of which 33 were found to use some form of activation. One important point that needs mentioning is that it was not our intention in this paper to comprehensively document every use of activation within cognitive architectures, but rather to identify common concepts and themes. We have tried to illustrate these concepts and themes with many examples from different cognitive architectures, but our examples are by no means exhaustive. Our motivation for writing this paper was to develop a lexicon and a taxonomy that could be used to precisely describe the different applications of activation within cognitive architectures. We believe that this effort will facilitate comparisons between cognitive architectures, serve as a starting point for standardizing notions of activation in the domain of cognitive architectures, and ultimately lead to the development of activation-related design patterns and best practices. In the first section of our paper, we establish basic activation-related terminology that can be used to describe applications of activation in cognitive architectures. For example, activation sources specify how activation is acquired, and activation targets specify what gets activated. Activation must also have some associated functionality that specifies what activation affects, facilitates, or enables within a cognitive architecture. Our functional taxonomy, which is described in a later section of the paper, is intended to characterize these functions of activation in a systematic way. Other terminology we describe in this paper include decay strategies, spreading activation, and activation thresholds, and we give examples of each of these from several different cognitive architectures. Our functional taxonomy has three main branches: representational, system dynamics, and measures of intensity or degree. These are further subdivided into additional branches at finer levels of granularity. The representational branch covers functions of activation that modulate the time-varying relationships between representations, determine the availability of those representations to modules and processes, and serve as informational content. The system dynamics branch characterizes uses of activation that modulate how operations are performed within a system, and the scheduling of events and processes. And finally, the measures of intensity or degree branch includes all applications of activation where an activation parameter's purpose is to serve as a time-varying measure of some property with a clear semantic meaning. For example, activations that quantify an agent's feelings of like or dislike associated with a stimulus. During our review, we discovered that the Lida cognitive architecture has one of the most varied and comprehensive adoptions of activation among the reviewed architectures, so we decided to test and illustrate our taxonomy using Lida. Lida, which stands for Learning Intelligent Decision Agent, is a biologically inspired cognitive architecture that implements and fleshes out significant portions of the global workspace theory of consciousness, as well as many other psychological theories. As you can see from this diagram, Lida contains many short-term and long-term memory modules. Lida also features special-purpose processors called codelets that come in two varieties: structure-building codelets and attention codelets. In our paper, we illustrate and test our taxonomy using many different examples from Lida. One of these examples is shown here. Lida's coalitions contain content from its current situational model that was advocated for by one or more attention codelets. These coalitions have activations that are based, in part, on the total activations of their content, as well as the base-level activations of the attention codelets that advocated for that content. The coalitions compete in a winner-take-all competition within the global workspace, based entirely on the coalition's activations. The winning coalition's content is broadcast globally, making it accessible to all of Lida's modules and processes. This example illustrates our taxonomic theme of activation controlling global access to mental representations. Therefore, it falls within the representational, availability, access, global branch of our taxonomy, which is highlighted on the right. This concludes our brief overview of our paper entitled A Study in Activation Towards a Common Lexicon and Functional Taxonomy in Cognitive Architectures. We hope you will read and enjoy our paper, and we look forward to hearing your thoughts related to its content.